Any quadratic equation can be written in the form ax squared plus bx plus c. But there's another useful form for us, which is called vertex form, which is listed right here. Below, we have two examples of quadratics that are written in vertex form, and let's talk about why this is useful. So starting over here, this is the graph of just y is equal to x squared, whereas this blue graph is x plus 4 squared plus 3. This form is nice because you can understand the entire graph in terms of transformations. Here this x plus 4 is changing the x, which means we go left 4 places, and then this plus 3 is changing the y values, which means you go up 3. Let's just do a little careful examination here. This point on x squared is really important. It's the point 0, 0, and it's called the vertex. We can easily figure out where the vertex is on this equation just by looking at where it falls, but also in terms of transformations. This point must go 4 places to the left. It then goes up 3 places, and here we have the vertex is at negative 4, 3. And really, if you understand how the vertex moves, you have an idea of where the entire graph goes as well. So again, this form here, this is not written in this standard form. It's written in a slightly different way, but useful in terms of understanding the graph. Now let's compare that to y equals negative x squared plus 5. Again, here we have y is equal to x squared as a reference of our starting point with the vertex still at 0, 0. We're not changing the x values. The graph does not move left or right. Now this negative 1 is being multiplied to the y's. That takes x squared and it flips it upside down. This plus 5 then moves the graph up 5 places, and so here the vertex on the graph is at 0, 5. So both of these forms, the standard form and the vertex form, have their uses. This was good for perhaps solving equations. This is better for understanding the graph. And the goal for this lesson is, how do you go back and forth between the two? Like if you had a quadratic that was written in standard form, how could you rewrite it into this form over here? So let's look at that in an example. So in example 1, again I listed y equals x squared as a reference, and then I graphed y equaled x squared minus 8x plus 21, and I got this equation here. Now this is not in vertex form, it's in standard form. Yeah, but the goal is I'd like to write it in this other new form. One way that you could go about this is by trying to understand how this graph changed in terms of transformations. I can see that it moved over to the right and then up. In fact, I know exactly how much in each case. The vertex goes over 4 places, and then it goes up 5 places. So if you're trying to just come up with the equation, this is going to be y is equal to, well, I don't want x squared. I actually want x minus 4 squared, because that's going to move the graph right 4 places. If I then want the graph to go up 5 places, I put a plus 5 at the end. I don't need a negative out here because the graph is not upside down, and I don't even need to scale it by multiplying by anything because it seems like every point on the graph is going over 4 and up 5 places. So I'm pretty confident that this thing is in fact my equation here, just written in this brand new vertex form. But I actually want to verify this. The way I can verify that this is correct is by squaring this out, adding 5, and just checking to see if it looks like this equation here. So this isn't very difficult. This is how you can go from vertex form to standard form. You can square this, add 5, see if we get the same thing. Okay, so if you square x minus 4, I think I'm going to be careful here and write that as x minus 4 times x minus 4 with a plus 5 at the end. And then just note that when I multiply this out, I have to distribute the x to both x and negative 4. This negative 4 gets multiplied into those parentheses as well. I get y is equal to, if I start with distributing the x, I get x squared minus 4x. If I then distribute in the negative 4, I get negative 4x, but then a plus 16 with this plus 5 at the very end. Okay, so then I have to combine like terms. x squared does not combine with anything, I do get a negative 4 and a negative 4x, which is negative 8x. 16 plus 5 is in fact 21, and this just verified our work. I came up with this vertex form just by understanding transformations, but then I just wanted to multiply it out to make sure it did match up with this thing here, and it in fact does. So I think it's pretty easy to go from a vertex form to a standard form. What's a little bit more tricky is reversing that process, so let's look at that next. Before we look at example 2, what I'd like to do is verify this above fact, where if you want to square something out, a pattern will always emerge for us on this other side. So to really talk about this, I'd like to square out both of these things and find a pattern between the two. So if we look at x minus 4 squared, we actually already did this, but just to write it out, this is x minus 4 times x minus 4. And if we multiply in the x, we get x squared minus 4x. If you multiply in the negative 4, you get negative 4x, but then plus 16. And when you combine everything, again, you get x squared minus 8x plus 16. The pattern that emerges is, if you have a negative 4 here, you can skip all of this work and just jump right to the very end to this negative 8. If you have negative 4 here, you will have double that amount here every single time. And that is what is being referenced up here. If you square this out with some number a, positive or negative, it's going to be twice as much in front of the x that appears over here. The other pattern that emerges is whatever number goes here, the square of it goes at the very end. And if you check it out, here we had a minus 4. If you square a negative 4, it turns into a positive 16. So there's a connection between the number here and the numbers that appear here. In fact, you should be comfortable with going backwards with this as well. If you see a negative 8 in front of this x, it would have to be a negative 4 that appears over here. Also, if you have this 16 here, and the fact that this is negative, that also tells me that this has to be negative 4 as well. So let's multiply this thing out. Let's try skipping all of these steps and just writing it out at the very end, noting that whatever number is here, I'm going to double it to put it in this location, and then I'm going to put the square of this number in this final location here. You get x squared. You're going to have a positive something in front of x, and it's going to be double that number 5, which is 10. At the very end, you're going to have the square of 5, which is 25, and that's what it looks like to use this fact to square out x plus 5. I encourage you to try that yourself, where you can go through this process like I did up here, and I promise that you will end up with this expression. But also, understand how to work backwards from this too. If there's a 10 here and it's positive, it would have to be a positive 5 that goes here. I introduced this fact so I can now use it in example 2. My goal is to complete the square on x squared plus 10x plus 28. And all that means is I want to write this thing in vertex form. What I'm going to do is start by subtracting 28 from both sides of my equation. The idea is to get the x and the x squared by itself, so just move this to the other side. The next step is to add something to both sides of the equation so that you end up with something that more resembles this, which would be something in vertex form. So to figure that out, you might already see the answer, but this is a very standard way to go about it. You look at the number that is in front of the x, and it is a positive 10. So I'll put that over here and just put 10. If I take half of this value, I get 5. And essentially what I'm doing is reversing the process up here. I see a 10 here, and half of that number takes me to 5. It's then the square of this number that goes at the end of my equation. So I first take the 10, divide it by 2, I got 5. I then square it to get 25. This is the number that I'm going to add to both sides of my equation. So that is, I have y minus 28. I'm going to add 25 on the left. I get x squared plus 10x, and then plus 25 on the right. you'll notice that this is exactly the same thing as this, meaning I can replace all of this with x plus 5 squared, and that's exactly what I'm going to do. On the left side, I'm going to combine like terms. Negative 28 and a positive 25 is negative 3. But x squared plus 10x plus 25 is the same thing as x plus 5 squared. To solve the equation back for y, I can add 3 to both sides of my equation. And at this point, I'm done. Y is equal to x plus 5 squared plus 3. And if you check your work along the way, if you were to reverse this process by squaring out x plus 5, the x squared gives you the 25, that was the number we added at the end, and double this number is sitting right here. That's why this method will always work. If you have a 1x squared, you can always take this value, divide it by 2, and then square it. That's the value that you're adding to both sides of your equation. And now that we have our equation, I can see what the vertex is. The vertex is equal to negative 5 for x, because it's moving 5 places to the left, and then 3 for y, because we're going up 3 places. And this is the answer to example 2.